Hello and welcome to aha-vts.com in association with Ahaliblogger.tech brings you this clipcast on Walk Like a Packet, Talk Like a Packet. My name is Alim H. And oh, by the way, I'm this handsome gentleman to the right. And in this clipcast, we'll go ahead and take a look at a layer 2 packet walk followed by a layer 3 packet walk. So let's get started. Alright, shown on the screen we have a simple network with 4 hosts or end devices connected to a switch which all reside on the same subnet. Now each device has a MAC address and an IP address. And for the purposes of layer 2, the IP address is moot and only the last octet is shown. The MAC address is a repeating sequence for each device. And we have 3 tables of interest, 2 ARP tables and 1 MAC address table. Now host 00 has some data that it wants to send to host RR. So host 00 determines host RR is on the same subnet and constructs a layer 3 header to attach to the data based on the source and destination IP addresses, which are .13 and .22 respectively. Next, a layer 2 header is required. Host 00 then proceeds to check its ARP table and finds out that it doesn't have an entry for host RR. And since the MAC address of host RR is needed to construct the layer 2 header, host 00 sends an ARP request to find the MAC address for the IP address of .22. Host 00 sends the request to switch X. And when switch X receives the ARP request, it makes note of host 00's MAC address and the port to which it received the request on, which is port 5. Switch X then proceeds to send the request out all ports, with the exception of the port to which the request was originally received on, and this is called ARP flooding. When host AA and CC receive the request, it drops it immediately since it doesn't have ownership of the IP.22. However, host RR accepts the request and processes it. Host RR learns the ARP mapping for the device that sent it, which is host 00, and updates its own ARP table. Next, host RR generates an ARP reply back to host 00, and this reply will be unicast in nature. When switch X receives the ARP reply, it proceeds to update its own MAC table with an entry for host RR and the port to which the reply was received on. In this case now is port 22. As this reply is unicast in nature, switch X will check its MAC table for the port and how to reach host 00. It finds that it can reach host 00 on port 5 and sends the reply out. Now once host 00 receives the ARP reply, it will update its ARP table with the MAC address of host RR. Now the layer 2 header can be constructed with the source and destination MAC addresses. And after all the pieces are assembled, host 00 can now send the data to host RR. And there we have it. Next, we'll go ahead and take a look at a layer 3 packet walk. As you can see, we expanded the diagram to include another network connected with a router. Now, the IP address for the purposes of layer 3 are significant. The network to the left have an IP network of 33.33.33.0/24, and the network on the right is 108.108.108.0/24. We also have additional tables of interest. We have 3 ARP tables, 2 MAC address tables, and a routing table. Now because router 1 is connecting these 2 networks together as directly connected, router 1's routing table is already populated. Now for the layer 3 packet walk, we have host 00 wanting to send traffic, however this time to host HH. So along with the data, host 00 constructs a layer 3 header with the source and destination IP address of 33.33.33.13 and 108.108.108.2 respectively. Now, at this point, host 00 determined that host HH is not on the same network as itself. Because of this, host 00 needs to send the information to its default gateway of 33.33.33.1. Next, host 00 will then construct a layer 2 header. It will check its ARP table for the MAC address that belongs to the default gateway. Like before, host 00 doesn't have an entry and will have to send an ARP request to determine the MAC address that belongs to the IP address of its default gateway of 33.33.33.1. When the ARP request reaches switch X will make a note of host 00's MAC address and the port on which it received the request. Again, port 5. Then switch X proceeds to send the request out all ports with the exception of the port to which the request was received on. When hosts AA, CC, and RR receive the request, they will drop it as the request is not destined for neither of them. However, router 1 will accept the request and learn the ARP mapping for the sender and update its ARP table with the MAC address of host 00. Now, router 1 will send a reply back. An ARP reply will be unicast and destined for host 00. When switch X receives the reply, it will update its MAC table with the router's MAC address and the port to which it received the reply on. In this case, port 48. Again, as this reply is unicast, host X will check its MAC table for the port and how to reach host 00. It finds that it can reach host 00 on port 5 and send the reply out. Once host 00 receives the ARP reply, it will update its ARP table with the MAC address of the default gateway. Now the layer 2 header can be constructed with the source and destination MAC addresses. After all the pieces are assembled, host 00 can send the data to router 1. Now, when the information is received by router 1 will strip off the L2 header and examine the layer 3 content. Router 1 sees the destination IP, then references its routing table for an entry, and determines that it needs to forward information out Ethernet 46, which is directly connected to the network 108.108.108.0/24. Because router 1 is directly connected to the destination network, router 1 must deliver the data to host HH. Router 1 doesn't know the MAC address of host HH and therefore must send an ARP request. So, router 1 constructs an ARP request to determine the MAC address for the IP address of 108.108.108.2. When switch Y receives the request, it makes note of router 1's MAC address and the port in its own MAC address table, then floods the request out all ports, with the exception of the port on which the request was received on. Host DD and PP drops the request as the IP address in the request are not theirs. Host HH will accept the request and updates its ARP table accordingly with the MAC address of router 1. Host HH will then send the ARP reply back with its MAC address. This reply will again be unicast to router 1. When the reply reaches switch Y, it will make an entry in its MAC table for host HH and the port on which the reply was received on, this time port 41. Since switch Y already have in its MAC table a port and MAC entry for router 1, it forwards the ARP request to router 1 on port 48. Once router 1 receives the ARP reply, it can now construct the layer 2 header with the source and destination MAC of router 1 and host HH respectively. As the new layer 2 header is constructed and added to the existing data and layer 3 header, router 1 can now send information successfully to host HH. And we're all done. But the question is, what about return traffic, if any, back to host 00 from host HH? How will that happen? Well, hopefully this diagram will sum it all up. So here we go. Host HH has returned information for host 00. Host HH constructs the data and layer 3 header with the source and destination IP addresses of host HH and host 00 respectively. Because it knows that host 00 is on a different network, it must send the information to its default gateway of 108.108.108.1. The layer 2 header has the source MAC address of host HH and destination MAC of router 1 as per its ARP table. Then, host HH sends the traffic to switch Y, which already have an entry for router 1's MAC in its MAC address table, and forwards information out Ethernet 46. Router 1 strips the L2 header and reviews the layer 3 information. Router 1 then consults its routing table and determines the IP 33.33.33.11 resides on the network 33.33.33.0/24 on Ethernet 23. Since router 1 is directly connected to this network, it must forward the information to its final destination. Router 1 has the MAC of host 00 from its ARP table and creates a new layer 2 header with the source MAC of router 1 and now a destination MAC of host 00. Router 1 sends the frame to switch X, which already has an entry for host 00 in its MAC table, and forward the information out port 5. Host 00 gets the information, strips off the layer 2 and layer 3 header, and processes the data. And there you have it, a complete end-to-end packet walk from both a layer 2 and layer 3 perspective. I hope you enjoyed this KLIPcast on Walk Like a Packet, Talk Like a Packet, and I thank you for viewing.